Today we're going to talk about graphing an inequality that has two variables. The problem we have here says that the elevator at FSA has a capacity of 2,100 pounds. If an average adult weighs 178 pounds and the average middle schooler weighs 83 pounds, how many adults and middle schoolers can the elevator hold? Well, there are many answers to this. I'm going to start by writing an inequality that represents this situation. I'll let X represent the number of adults that can fit on the elevator, and I'll let Y represent the number of middle school students who can fit on the elevator. So the inequality I would write would be 178 times the number of adults plus 83 pounds times the number of middle schoolers. And that total weight has to be less than or equal to 2,100 pounds. I'm going to create a graph that represents all the possible combinations of adults and children that can be on the elevator at any one time. So the best way for me to attack this graph is to find out what combinations will put the elevator at its maximum weight, which is 2,100 pounds. So I'm going to start off by graphing the equation 178x plus 83y equals 2,100. And looking at this formula, it's in standard form. And so the easiest coordinates for me to graph for this formula are the X and the Y-intercepts. So to find the X-intercept, I already know that my Y value is going to be equal to 0. So I'm going to plug in 0 for Y. I get 178x plus 83 times 0 equals 2,100. And so I have 178x equals 2,100. Divide both sides by 178. And I get approximately 11.8 is equal to X, which means X represents the maximum number of adults. So it looks like when it's at capacity, just under 12 adults, or simply put, 11 adults can fit on there at any one time. So that's my first coordinate, which is 11.80. Now the other coordinate that's easy for me to find is Y-intercept, and I'll do that by replacing X with 0, and I now have 178 times 0 plus 83y equals 2,100, means 83y equals 2,100, divide both sides by 83, and I now get y equals approximately 25.3. So that represents the maximum amount of kids that can be on the elevator at any one time, which is 25. So that coordinate would be 0, 25.3. I'll make this graph, and you only need two coordinates to plot your line. I'm looking at my scale here. I need to get up to 25 on the y-axis. On the x-axis, I need to get up to 11.8. I'll plot the coordinate 11.80 and start my origin. Start at 0, go up to 25.3. Connect those two coordinates. And it looks like these are all the combinations that will put me at an exact weight of 2,100. And of course, we want to stay under that mark as well. So let's see if we can find some possible combinations that are less than 2,100 pounds. Well, an obvious combination would be if you had no adults and no kids. So that was 0, 0. And when I plug this into the formula, I get a true statement, of course. And if you found one solution, you can find all the possible combinations that work here. So just by looking below the graph, I would see, what about 8 adults and 2 kids? Let's check that. So it looks like I can shade below this line here. And I'm going to stay on the positive x-axis and the positive y-axis since this is a real problem here. So I'm not going to have negative x values or negative y values. So I'll just shade kind of within this triangle here to represent all the possible solutions. Now, of course, if I'm allowed to have negative numbers for x and y, then I would shade everything else that's below this line here. The line represents where you have an exact weight of 2,100. So it's a solid line here. But if I'm on an elevator, I don't think I want to be at capacity. I'd want to stay under 2,100 pounds. So if my formula was 178x plus 83y is less than 2,100, I would still need that boundary line where it equals 2,100, because that way it lets me know that everything below it works. So essentially a boundary line separates the right answers from the wrong answers here. And so if I did not want to have the equal part as a part of my answer, I would have a dotted line here. It's almost like an imaginary line here that just separates the right answers from the wrong answers.